everyone, and welcome. I'm Farron McEntee, Associate Director and Senior Fellow for the Dana Foundation Career Network in Neuroscience and Society. I'm delighted to be here with Dr. Corey Keller, an Associate Professor of Psychiatry and Behavioral Sciences at Stanford University. Dr. Keller is a leader in translational neuroengineering, known for his work using brain stimulation to develop personalized treatments for mental health conditions. He's also an MD, PhD clinician scientist whose career spans academia and the neurotech industry. He's also deeply committed to mentoring the next generation of neurotech innovators. Dr. Keller, thank you so much for joining us. To get us started, could you introduce yourself? Tell us a bit about your current role and research focus, and share your pathway to your current position.
Yeah, thank you. It's lovely to be here. It's an honor, and thank you for that introduction. So, currently, I'm an associate professor of psychiatry at Stanford. I wear several hats, but my main two are a clinician. I work at the VA 2 mornings a week, delivering brain stimulation and esketamine treatment for those with hard to treat depression. And I run a research lab focused on brain stimulation and inducing neuroplasticity to treat mental health disorders. My pathway has been windy. I started out as an electrical engineer in college, added on biomedical engineering, and did the pre-med classes. After college, I wasn't sure what I wanted to do. I applied for a bunch of research assistant jobs that allowed me to see patients and dive deep into research. I ended up in an epilepsy lab in Boston, doing microelectrode recordings in patients that were implanted with intracranial electrodes, which I found fascinating. That was really my first introduction to neuroscience. I had never taken any classes. That pushed me towards the MD PhD program, and I'm happy to dive into detail as to that decision. Continuing that research, we were developing brain stimulation tools invasively in humans, and then got really interested in psychiatry, connected with the patients, and found this space of applying brain stimulation to modulate specific brain circuits in this field called interventional psychiatry. And so I did a postdoc in residency at Stanford, did a foray into neurotech space and co-founding Alto Neuroscience. I'm happy to talk about all these decisions, and then came back to start my lab in 2021, focused on invasive and non-invasive brain recordings and stimulation modalities to help treat patients with mental health disorders.
So, you kind of touched on this already, but your multi-sector and translational path, what was it about your research assistantship that kind of, pointed you towards the MD PhD pathway?
Yeah, it's a great question. Um, I shadowed my PI, who is an epileptologist in the clinic, and I fell in love with seeing patients. And I knew the medical school, the MD, was going to be my path and what I was going to spend some of my time. And I really enjoyed the research, but the research was not, I wasn't committed to running a lab, and so I actually wasn't sure I needed the PhD. I ended up applying to MD only programs. And in the summer between my first and second year of medical school, I continued that research and really just fell in love with it and knew that I wanted to run a lab and I wanted that to be 75% of my time. And so I was actually able to transfer into the MD PhD program. Some programs have 1 or 2 slots available for PhDs that want to join the MD PhD program, or MDs that want to join the joint program. So I got very lucky there and transferred in and continued that path. And as such, probably 80% of my time today is running that research lab, and I feel very passionate about it.
Thank you. And so, as I understand, your current research is really involving personalized psychiatry. And so I'm just kind of curious in how you arrived within that, that sphere.
Yeah, I've always been fascinated with how brain stimulation actually changes the human brain and how those brain changes eventually trigger a symptom response or a clinical response. And we don't have that figured out at all. And there's a number of reasons why. And so we've had to do a lot of tool development to come up with measures to quantify brain excitability and brain plasticity in humans. A lot of this work came from animal models that we translated, but we don't have the neuroscience tools to actually probe the brain non-invasively or invasively and try to understand this. So the first question I've always asked is, what does this brain stimulation do to the brain and how do we quantify that? Once we figure that out and understand those principles underlying how certain patterns of stimulation upregulate or downregulate specific circuits and why that might be, then we can think about applying different types of brain stimulation, different patterns and intensity, and different targets to start to personalize based on the symptoms someone has or the brain circuit abnormalities that someone has. And so it's been a foray into using invasive brain recordings, which are sort of ground truth electrophysiology, to understand what brain stimulation does. Then, with simultaneous non-invasive EEG, can we actually translate those invasive recordings non-invasively so that we don't need surgery to actually understand these and measure these and can actually be brought into the clinic? Then we can start to play around with things called like state dependence. So understanding what that brain state should be at the time of stimulation to maximize the amount of plasticity, closing the loop, so monitoring in real time and actually adjusting the treatment parameters to maximize the clinical effectiveness. So there's a lot to do once we answer those questions of what's the mechanism of how brain stimulation actually changes the brain in humans, and how do we quantify that, and how does that translate non-invasively? Is there a signal that we can reliably measure and track in real time in the clinic? And that I think will really revolutionize the space if we have that marker of brain plasticity that eventually will translate to clinical response.
Thank you so much. And so we've talked about your pathway to the MD PhD and post, post earning your doctorates. And so then you went into a residency and then a postdoc. And so how did that lead up to your role in co-founding a neurotech company?
Yeah, it's a great question. All to say, coming out to Stanford, I had no interest or desire in the neurotech industry space. I came out for research. I was working with Amit Etkin, my PI at the time, and to get clinically trained. During that postdoc, we came up with some really interesting findings. We were trying to look at EEG biomarkers to predict treatment response for those patients that were getting TMS or brain stimulation treatment for depression. We were scaling it up and realized that it was actually something that clinics really wanted. And we sat down together and decided to start a company around it. And we didn't really know what we were doing. We learned along the way. I was lucky in that I was able to secure a faculty position and then take a leave of absence. So I had a year that I could go full time at Alto and then come back and start my lab. So I hadn't started my lab, which was a good thing. Um, and then it was, for me, it was a question of regret, is that if I didn't jump and, you know, my colleagues were starting this thing a mile away and I hadn't agreed to take that risk, that would have been a larger regret for me than jumping, failing for a year, and then coming back and starting my lab. So it ended up being an easy decision, but it was a really difficult decision at the time. But a lot of things lined up really nicely, and the risks were relatively low, although I almost did have to give up a couple grants that I had. But I've had a lot of support along the way from department chair to the NIH and to my close colleagues that allowed me to take that leap, and my partner supporting me, of course. Um, so yeah, it was a relatively straightforward decision in the end once I de-risked the decision enough, but still a risk. And with any risk, there's potentially a large payoff. And in that, I learned an enormous amount at Alto. And there's always some innate risk in making that decision. There's no right answer, and I'm generally pretty conservative. That was one of my first um, I would say, pretty risky decisions. And as a result, I've also realized that a lot of good things can come from those decisions. And I've been making more of those recently. Yeah.
Thank you so much for sharing that story. I
Well,
can't even imagine what it would be like jumping out of, a training period to being a co-founder and you were a chief medical officer. So would you mind talking a little bit about what your day to day looked like in that state? I guess it probably never really looked the same. But could you give an
yeah.
idea of your range?
Yeah, it's been a while, so I need to remember, but it was wearing an enormous amount of hats every single day, right? When it's just four of us starting a company with some funds, what do you do? It was everything from making a website to figuring out a credit card choice to finding a logo to finding an office to talking about the science strategy to developing the clinical trial infrastructure to guide these clinical work. Interfacing with clinics that actually believed in us and wanted to be early adopters and wanted to work with us. Um, Getting a lot of mentorship for me around the FDA, insurance, managing a team, hiring people. Um, it was so much every day, and the learning was just exponential. We were all doing it with experts around us. It was a lot of fun.
Thank you so much. So now we're going to transition a little bit. Your journey really shows how many different avenues there are for clinician scientists to shape the future of neurotechnology. From the clinic to the lab to industry and back again, something that stands out across all of those roles is how committed you've been to making the field more accessible to the next generation. I actually learned about your work through LinkedIn. We had a mutual connection who commented on one of your posts. And I was really struck by how accessible you are and how much you share with the broader community. It's not really something you necessarily see every day in such a fast moving field. So, my next question is, what motivated you to make yourself so accessible to students and early career researchers?
Yeah, thank you for saying that. Um, This was over the past couple years, I've had a lot of students reach out to me, high school, college, grad students, asking for some career advice. And this was before I started posting on LinkedIn. And so I would spend a lot of my, drives in the morning talking to these students. It was 7:30 in the morning, and on the West Coast, my lab isn't really awake yet. So I was talking to a lot of East Coast and European um, people, and I really enjoyed it. And I figured why limit it to people who are just emailing me? And so I ended up posting on LinkedIn and sort of opening up my calendar for that slot, that once a day slot, and it kind of blew up. That coupled with the support of people saying, keep doing this. This is awesome. We really appreciate it, coupled with the recent passing of Nolan Williams, which has been tragic, and the realization for me that, life is short. And I think I've always been scared to put things out in public, put ideas, thoughts, interviews like this, worried that I was going to mess up or say something wrong. And just realizing that, I might have things to share that people might want to hear. And it's, before you know it, it will be too late. And so I think those couple things coincided, and I started posting and learning and figuring it out. And it's a whole different space, whole different game to play, and also figuring out how to balance that with my day job. Has not, it's been how do I make this a very small portion of my day, but I am very passionate about it. I've always been passionate about mentorship. It's partly why I'm running a lab, is to be able to mentor the next generation of scientists and grad students and postdocs. And one thing I'm always worried about is, will the mentorship piece supersede the science? Will I be known to some people as that mentor in this space? But when I think about that, I'm okay with it, right? It's that something that I'm okay being known for that a little bit more than my science, and hopefully, the science will catch up. But so it's something I'm passionate about, and I enjoy it, and doesn't take away. an enormous amount from my day and figuring it out. It's, you know, I've treated each of these things as challenges and trying to learn what that game is and how to play it and how to do it well so it's actually helpful for other people, what I should be saying, what I should be posting about, how I should be communicating so that it's helpful for other people. Because otherwise, what's the point? So that's where I'm at right now. We'll see where it goes, but it's been fun. And it's been fun meeting people like yourself and other people in this sort of neurotech mentorship space. And there is a lot out there. Um, and so it's been fun being part of that community for sure.
Okay, so building on that question, do you have a larger vision for the community that you've been building? Do you envision any types of partnerships or meetups? So I'm just kind of curious about that.
Yeah. Um, the honest answer is no, not at all. I am figuring this out day by day. That was true for Alto. That was true for my lab. That was true for this windy path. You know, I do what is fun. The intersection of fun, passionate about, I think helps people and, you know, can lead to some, you know, success and stability in my career. So I think as long as those intersect, I'm excited about it. So I'm definitely excited about this. I don't want it to be my full-time job. I've thought about things from a Slack channel to a website to, you know, weekly or monthly Zoom meetings and trying to figure out what already exists in this space and what is actually needed and how to provide that. And so I'm still exploring. I don't know what that answer is. I think people appreciate some of the posts and they appreciate the one-on-one calls that I have, and I'll enjoy that and continue that. But as I start to think about building something larger, then I go and find that that actually exists in the neurotech community in this other space. And so I don't need to build it. So still trying to figure out exactly what that is. But there's certainly a lot of gaps in this community in how to find a job, in how to be able to communicate to people who would actually be doing the hiring, to grad schools that don't provide much resources in terms of how to actually find a job in industry and how to position yourself. Um, so there's definitely gaps, and there are people that are filling that gaps as those gaps as well. So it's just fun to be a part of it.
So um, I'm going to pivot to, I guess, having you put on your mentorship hat, particularly in the neurotech space for aspiring founders. So for those who are curious about entrepreneurship or thinking about launching something of their own, what advice do you have for them?
It's a great question. Um, so what advice do I have for people thinking about founding a company? I think the first couple questions usually um, are regarding personality, ability to put in the hours and work hard. Do they want to be a leader? I think people think about being a founder or CEO and it looks like all fun and games, you know, and the way that it's portrayed on social media and in movies, but it really takes a certain type of person at a certain point in their career to want to and need to start a company. So that's usually the first question is, do you know what you're getting into? Do you want to be that leader that works their butt off, that is starting something completely new, is willing to fail? You know, that's it's a certain type of person compared to an independent contributor at a, you know, 50,000 person company. And so making sure that that's the right path for them. You know, in all of my conversations, I've realized how important networking is and having that network and knowing how to, you know, pull out that Rolodex, whether it's as a founder, knowing other founders and learning about their journey and what worked and what didn't, um, you know, venture capitalists and investors and knowing who to text when it comes time for that fundraise in order to have those warm intros And then hiring people, right? Having teams of engineers and neuroscientists that you can connect with instantly that will want to jump the second you say, "Hey, I'm starting this thing." So all of those can be really valuable, and it takes a lot of time to build that up. Um, but it is an exciting space, and there's a lot of funding rolling in. There's a lot of opportunity. There's a lot of scientific discovery in the neurotech space. So this didn't really exist 10 years ago. So I'm excited to watch it, be part of it a little bit, and help out, where I can.
Thank you. And so, as you think about your field, the precision psychiatry space, what are you most excited about building on or supporting?
Yeah, for me, I think brain stimulation is entering a newer age, and things I'm really excited about is using and leveraging brain state as thinking, people in the clinic will stare at a wall when they get treatment. And we know in animal models that you have to activate those brain circuits at the time of stimulation in order to actually induce neuroplasticity and get a clinical effect. So I think we are finally at that point where we can start quantifying these things in real time and pushing around the brain in real time in a way that can have an enormous effect on the brain and on neuroplasticity and the clinical effect. And pairing neuroplasticity tools with other types of interventions, I've become recently very excited about. So pairing TMS or brain stimulation with stroke recovery or with there's a lot of training and interventions that do not involve brain stimulation for neurological and psychiatric disorders that can be paired with brain stimulation. So can you get a dose of TMS right before you go and do that other intervention, whether it's stroke recovery intervention or some cognitive training, and do it in a methodical, rigorous fashion that you can actually quantify. So do you do it right before, during, or after that intervention? What type of stimulation do you apply for how long? And so it's not just the stimulation itself that is doing the hard work. It's opening up that window of plasticity and allowing these other more physiological, naturalistic interventions, whether it's cognitive training or stroke recovery, to do the work, but it's going to be more effective because you just got the brain stimulation alongside it. Those are a couple spaces. Other things, focused ultrasound is really exciting in terms of being able to get millimeter resolution deep in the brain. Um, there's still a lot of gaps in this space, but there's a lot of exciting paths forward.
Thank you.
Yeah, thank
Thank you
you.
so thank you so much for sharing your time and your insights. Your work is a powerful example how science and technology can drive meaningful social impact when mentorship, innovation, and community building come together. To everyone watching, we hope this conversation sparks new ideas about the future of neurotechnology and how you can be a part of it.
Thank you.